Welcome to Automating Screenshot Testing in a Component Library with David Lindley and Ben Hudson. David Lindley is a software engineering manager at Vodafone UK. He is the technical product owner of Vodafone's global web component library and has a passion for quality and ensuring that technologies are used to correctly meet users' needs. Ben Hudson is a senior software engineer for Vodafone UK, working on the global design system. A middling designer that has learned to code, he has retained his passion for clean UI and reusable, accessible components.
Fantastic. Well, thank you very much. Thank you for having us here this afternoon. So we're going to be looking at automating screenshot testing in a component library. Before we dive into that, let's give a little bit more information about myself and Ben. So as Pam correctly said, software engineering manager at Vodafone. I've been in the role for about 4 years. Been doing web development for about 9 years. I wear many hats, none today. But the one that we're going to be focusing on today is that technical product owner for SourceWeb, which is that global component library. In my spare time, I enjoy walking, video games and playing guitar, although most recently I haven't had any time for that because I've just had a newborn son. So my time is spent burping and changing nappies.
Thank you, David. So I'm Ben Hudson. I'm a senior software engineer. I've been a developer for 13 years, and I've been working on the SourceWeb project for the last 3 or so years since it started. In my spare time, I've also got a young little girl who's 2.5, so I spend a lot of my time with her. And if I'm not there, then I'll be on the golf course. That's me.
Fantastic. So today's session, what can you expect? So we're going to talk about Vodafone engineering, which is where we come from, a little bit about that and why that's important for this sort of presentation. We're going to dive into what SourceWeb is, the technology stack, the decisions we made. We're then going to talk about Applitools, how we use them. And then we're going to do a bit of live coding, and Ben's going to take us through auto-generation of tests, basically what we did to how we solved some of the problems we had with a component library and testing. So the presentation we split about 15 minutes of presentation, then the rest will be sort of coding, and Ben will be taking us through and sweating profoundly as he tries to code live, because live demos never go well. But I have every faith in Ben that it'll go fantastically well.
It's one of us.
Thanks. So let's start with global engineering. So about 2 years ago, Vodafone made the decision to unify our engineering arm together. We have got Vodafone bases across multiple areas in Europe, as you can see on the map there. And with that, we wanted to bring together the best of all the engineers across all these markets into one place. So we could sort of use the scale of Vodafone to build things quicker and more effectively. And that point there, maximize possible reuse while accelerating market maturity and outcomes. That's exactly where myself and Ben fit in this. We work on a project that helps do that. And so what we've sort of come up with and what we're developing and what we're showing you today is one of those reuse projects, and it's used across multiple places. We presented at React Summit, and we've also done another previous webinar for Applitools. I'm sure that will be shared afterwards as well, where we go into a little bit more detail about certain things we're talking about today. So if you're interested in that, please do reach out, and I'm sure they'll be shared after the presentation. So SourceWeb, well, what is it? At its heart, it's a component library. So it's a React component library with about 220 components split into atomic design principles. So you've got atoms such as buttons, all the way up to organisms such as full page templates. And when the Global Engineering Initiative kick-started, we did a bit of piece of work to try and work out what was available to web engineers across markets. And we found that every market had pretty much made a component library. It's quite a standard thing for people to create in web engineering. And so we wanted to try and utilize the Global Engineering Initiative to bring it all together in one place. And that is where SourceWeb came from. It started off in the UK, so the UK is base, and it's sort of migrated now into being used across multiple markets, 6 markets as of today, with the aim for it to go across all markets in the next couple of years. It's got 500 unique developers consuming and contributing to the library daily, so we've got a lot of changes going into it and lots of people using it in their projects. And we've had 70,000 unique downloads in pipelines and individual contributors as well. So it's not a small library by any stretch of the imagination, which is where, as things scale, things become more complex. And we'll go into that in a bit more detail. I'm now going to show a quick video which outlines some of the other benefits that SourceWeb brings and shows you a little bit about it in a bit more detail. Great. So from that, you can see SourceWeb is growing. I mean, when that video was put together, there was only 227,000, and since then there's been 70,000. So it's constantly growing with developers and contributors. So in terms of the tech stack behind SourceWeb, we use Learner. So we use Learner to do individual component publishing in a mono repo, and we publish on our private NPM repository. Unfortunately, it's not currently open source. It's something we are looking forward to doing in the future. We have a lot of Node tooling, and some of the stuff Ben is going to be doing today uses Node. We use Azure DevOps for our pipelines and our CI/CDs and our Git. Our testing strategy is quite extensive. So we use Jest and Enzyme. That's just a throwback to when the library was originally done. We are currently researching React Testing Library as a potential option for unit testing. We use Cypress with Cypress Axe and Applitools for our visual regression and interaction and accessibility testing. In terms of the actual components, they're built with React, TypeScript, and style components. TypeScript provides us a really clear prop interface, so when consumers come to use the library, they can easily use it and understand what props they're going to use. And the big one that we're going to be talking about today is the doc site. So the thing that you saw in that video, that is the doc site, that is our shop window, and that uses React Style Guidist. And we're going to talk about why we chose that and the problems we encountered when choosing that coming up. So, having built the library, we really wanted to ensure that the quality of the components we built were high. Because this is used in so many markets across the globe, we want to reduce the strain of testing in those markets so they can test what's important to them, not the actual components themselves. So we have a very robust testing strategy. And last year, about a year and a half ago, we onboarded Applitools, and we wanted to do visual regression testing on our components. And we wanted to quickly do this. And we talked to Applitools, and they were like, great, you've got a component library, fantastic. We've got integrations for Storybook. And we were like, we use Style Guidist. That's a bit of a challenge because we didn't want to have to go through every single component and integrate every single component manually. If you look at the bottom here, we've got 220 components with 3 themes and 10 variations. That's 6,600 screenshots total. Including that doesn't even include breakpoint changes. If we want to look at components at mobile, tablet, and desktop, that's a huge number of components that we need to test very quickly. And we didn't want to do this ourselves. I mean, Ben's job is hard enough as it is, rather than writing 6,600 screenshot tests. So why did we use Style Guidist? Applitools has got integration for Storybook. It doesn't have an integration of Style Guidist. And it really comes down to our problem statement. who are our users? Well, our users are software engineers, first and foremost. They use this component library daily with what they're building, but also product owners, business owners, UXers, testers. All of these are users of the doc site and our components. And so we were really keen to make sure what we showcased to Vodafone as a whole wasn't just an engineering side. Storybook is fantastic, don't get me wrong, we love it. It has a simple setup, lots of integrations, very easy to use. But from our view, it was very much focused on engineers, not on product owners, business owners, UXers, testers, etc. It didn't give a very easy way to see how things were showcased. So we decided to use React Style Guidist, primarily because it allowed complete customization of the look and feel. We could easily change it to look exactly as we wanted it to look like. We changed it to look like Vodafone, and we wanted to use it as a shop window for the components. And you could see that in the doc site that we demonstrated. It wasn't just for engineers, it showcased a really good way of showcasing for anyone wanting to use the components, how our components look. So once we'd made that decision, we couldn't really go back. You know, people like the way the doc site looks. We couldn't really pivot to use Storybook at this point. But I did leave with a problem. What do we do? How do we create visual tests for all the components, given there's no integration for Style Guidist, without burning through developers' effort? And as I said, Ben wants to be on the golf course, not writing 6,600 screenshots. So we started looking at options. And if you look at how React Style Guidist works under the hood, essentially it works with, you have your component files, which are JavaScript files or TypeScript files in our case, and then you have an MD file, which showcases basically the examples for that component, and you write these yourself. And we'd already written these, and then what happens is Style Guidist uses these two things to combine together to showcase different example files on their doc site. So we'd already done the effort of writing these MD files. So that gave us an idea. What do we do with those MD files? So if we use those MD files as our starting point, given that they showcase all the variations and all the differences we want to see in our components, then we can sort of use some sort of level of automation to generate Cypress tests out of them, and therefore auto-generate the visual tests out of them as well. So we thought, well, can we parse these? Is it possible? What can we use? What tooling can we use to easily generate Cypress tests out of all the MD file examples? So if we start, we're going to start by doing this today. That's what Ben is going to showcase us in a few minutes. We have created a webinar card for this very purpose. We're going to just do one component to start with, just to showcase how it works. And you can see here, this webinar card has got a company logo, title, subtitle, and pictures and names, and a favorite icon. This is all built up, by the way, with our components. So myself and Ben built this very quickly, just to showcase the benefit of the library. And then we'll showcase this in more detail. So we want to quickly test this. We don't want to have to write any sort of manual Cypress tests with this. And Ben is going to showcase how we can do that. So this is a sort of a flow diagram of what Ben's going to go through. We're first going to look for all those MD files. So we're going to find all the MD files we need for all the packages. We're then going to read them to work out what we can do with them, what data can we grab out of those MD files to easily find ourselves some sort of benchmarks to work on. We're then going to look at splitting those by example, which Ben will show in a minute. And then we're going to use templating to template into some Cypress tests and write them to files. And that should give us automated Cypress testing. And that leads me nicely on to handing over to our resident coder, Ben Hudson, who's going to absolutely smash it. Over to you, Ben.
Thank you very much. Just to preface this with the fact that I've been on holiday for a week, so I've forgotten how to code almost entirely, but I will try my best to get everyone through what we've got. So I'm just going to share my screen now. So this here is our source web library. This is just the homepage of it. So if I head through into that component that we built, we've got the webinar card here. So what we do and what we try and do with all of our components in order for this automation to work as well as possible, we will always try and split each one of our props into like a sort of separate example so that we can properly isolate what's happening and what we can see. So as you can see here on the webinar card, we've got the two appearances which show sort of every prop that's available in one go. Then we show it where it's not favorited. So this star is not blue in either of these examples. And then we have another example here without this subtitle. So we now know we've got what happens if it's not favorited, what happens if it doesn't have a subtitle, what happens if you throw the kitchen sink at it. You will get an example for each one. And this is a pattern that we repeat all through our components. So we always try and say, what are the appearances of the button? We've got the inverse set up differently. We've got states, inverse button state, etc., etc. So every single time we have a different example for each prop. So if we go back to the webinar card, this is it in action. And then over here, this is the markdown file that we have. So before each example, we just have a simple heading 2, and then we go into our JSX code. So we've just got, this is our first example with the appearances, second example without favorite, and then the third example without subtitle. So what we need to do for each one of these is give it a unique ID for each test. So we put an ID onto this div, and we normally just call it VT-1, and then we will then sequentially go up. So VT stands for visual tests, and then I can go VT-2, and ID equals VT-3. So that's the markdown file done. That's all we need to do to do this. And then obviously as we add new examples, we just need to make sure that we've got a unique ID for each one. So then we go into the test generator. So this is like a rough skeleton for it. So at the top, I've got all of the imports that we're going to be using, and I've got our typing sort of set up here because we do use TypeScript, as David says, and then I've got a very simple function here, which I won't really go into in too much detail. This is called write test file. Just returns a promise where it basically goes through an EJS template and renders the file that we will go out in the end, and then we then save that file to the output directory. That is just EJS stuff. So as I said, I won't go into that in too much detail, but we will go through writing the actual template itself for it. We've also got like a very rough a markdown file parser function, which we'll write up as we go through. And this is sort of the bulk of it. So this is our generate tests function. So I've just got an initial constant in here at the start, which is our blank Cypress UI template EJS file. So the first thing I'm going to do is I'm going to go through our folder structure and get the package directory. So as David said, the whole library is a learner-based repository. So we know that every single one of our components, because we've got a component generator and all sorts of stuff, it is in the exact same format. So we always have like our component name at the top. Then inside there we've got a package.json file, and then all of the action, all of the markdown file, TypeScript file, everything happens in this source folder. So we've got a very repeatable pattern. And what we've tried to do as much as possible for all of this is make everything as repeatable as possible so that we can bring in automation, so we know what we're going to expect. So we have our sort of source web tooling folder. This is something that we've written ourselves. This is just like gives us a load of functions that sort of go through and help with that sort of decoupling process that David was talking about. So in the same way we want to decouple from Style Guidist, we also, in the long term, particularly given recent events, sort of want to decouple a bit from Learner and be a lot more in charge of our own destiny. Because I think before I did the last session, it was like a week after they'd announced Learner wasn't really supported. So that's something we're doing moving forward. So we've got this this tooling folder that allows us to do certain things. So for instance, I'm going to set up a new constant and I'm going to call it package JSON directories, and that's going to await a package that we call find local packages. And it's just going to go through that source folder that we pass in here. So when we run this function, we're only at the moment using it for this one webinar card. So we've been very prescriptive in the in the source folder here. So it's going to go through, and then that, once that is done, is going to give us an array that looks like this. So it's going to give us an array of paths. So when we pass in our entire components folder, that's going to give us about 220 different strings with all of these package.json files. So now that we've got that array, because it's asynchronous, we need to run a for loop. So I'm going to say for, I'm going to say let I equal 0, and then I, oh, that's the wrong one. That's the first typo there. I don't know if anyone's clocking that. It didn't take that long. Package JSON. Well, there's the second. Wow. I'm just going to, yeah. I'm going to copy this. Dot length. Is that giving you anything? Yeah, that's fine. And then I plus. And then we're going to split up. So we've got this string here. So we need to get that as a path. So we're just going to split it up by the slash. So we're going to say split directory equals package JSON does I split on the slash. And then that is then going to give us another array, which is going to look like this. So then each one of those will be a separate array. Now we know at this stage that we just want to discard that package JSON. We don't need it for our purposes, so we're just going to split that down. So we just want the component directory. So we're going to create a new const here, component directory equals split directory slice 0 minus 1, and then that is going to give us just the array without the package JSON. So we're going to have something that looks like that, and then I can then go and get that component name, because we're going to be using that later on. So I'm going to say const component name equals component directory length minus 1. And then that is then just going to give us simple webinar card here. So then we're going to go into a try catch here to go through the parsing of the markdown file and getting the stuff that we need out there and writing those tests. So I'm going to write a try, and then underneath I'm just going to put the catch with an error, and I'm just going to console log out the error. There. So now in our try, the first thing we need to do is we need to get that markdown file. So again, we've always got that repeatable structure. We know where the markdown file will always be. So I'm going to create a new const, which is md file path equals, and I'm going to use path so that we are agnostic to operating system. So I'm going to join, and then I'm going to just spread the component directory in. And then we know that it will always be in the source folder, and it will always be called component name .md. And then that for each one will give us this when we run through it. So that will give us the path of being source, components, molecules, cards, webinar card, source, webinar card.md. So we've got our MD file there. We're then going to put a little bit of a safety check in around, so we're just going to use file system to make sure this actually exists. So I'm going to go if fs exists sync, which is going to be the MD file path. And then, so if we've got that, then we're going to go ahead and read that file. So we're then going to run a const md file equals await fs dot read file md file path, and then I want to encode that into UTF-8. So then that markdown file is literally just going to load in this entire thing here just as a string. So that's obviously not especially helpful for us at this stage. So what we're going to do is we're going to come up to our next function, the parser, and we're just going to pass that markdown file. So I'm going to write a new constant here, which is going to be const test equals parse md file, and then we're going to pass in the md file. That's going to get us up into this function here. So this is called parse md file. And what we're going to do with this one is we're going to use a package called md2json. So it's up here, and it will give us something like this. So it basically takes the markdown file, which will look like this, and then it will convert that into a JSON object. So it will nest it all. So it gives us our heading 1, which creates a node for that. Then you get the raw content underneath that. So we've got our paragraph and our list. It just comes in with like /ns for new lines. And then we then have our heading 2. And then for each one of those, you get a brand new node. So we need to use that in our parser up here. So I've added in a few starter constants. So we've got tests, which is going to be an array of test data. So if we go into our types file, you can see that test data is going to give us a selector ID, which is going to be just a string, the title, which again is a string, and the test title, which is also a string, but one of them is going to be camel case and one of them isn't. So if I now come in here, so I'm going to say const parsed file equals md to JSON dot parse. Now, the thing that you may have noticed when I showed off this is that this package here will always start with a heading 1 here, so it gives us that nested structure straight away with that heading 1. But all of our markdown files don't have a heading 1 and they all have heading 2s. So what we've had to do is sort of fake it a little bit. So we've got this initial prefix here that we put in as a sort of fake H1 at the top. So we're going to put in like a string literal here, and we're going to put in our heading 1 with prefix here, and then I'm going to put in a new line, and then I'm then going to put in the rest of the string. So we're going to put in that markdown file, and then that is then going to go through that entire file for us and give us this output here. So it's going to look something like that with our sort of, so you're going to have appearances, without favorite will be its own node, and then without subtitle would also be a node underneath. And then you get this raw content as part of it, which gives you the rest of what we want. So we can then start looping through this here. So I'm going to use object.keys, and I'm going to use my parse file, and then I'm going to pass in that prefix because I don't want that first level. I want to come in a level here. So I'm going to pass that prefix in there, and then I'm going to run for each, and then I'm going to use title, because then for each one we will have that title there. So we'll have like appearances and without favorite and without subtitle. So I'm then going to create a constant here. So I'm going to get the const raw contents equals parsed file prefix title dot raw, and then that will then return us basically all of this. So this whole sort of JSX file here will go into our raw contents. So then once we've got that raw contents there, again, we want to just make sure that we put a bit of protection around this in case it's not found. So we're just going to say if there is no raw contents, then we're just going to return here. So now we need to do a bit of regex to find that this ID for each one here. So we're going to go through the raw contents, and we're going to say const match results equals raw contents dot match dot match, and then again, and then we're going to use a bit of a string literal here. So we're going to say we want it to start with ID equals, and then because we can't be sure whether they're going to be using double quotes or single quotes, we can just say either a double quote or a single quote, like that. Then we can put in our test prefix here, which is that VT there. So test prefix dash, and then we know it's always going to be, it can be anything here, so it can be any character. So I'm just going to dot plus question mark, and then we know that it's then going to close at that point. So again, we then just want to do this either double quote or a single quote there. So that is then going to get it. That's then going to return us an array from this raw content. So the first item in the array will be everything up to there. That will be the first item in the array. Then our second item will be this, just the -2 or -1, and then the final item will be the quote all the way down to the end of that raw content. So the only thing obviously we're concerned about here is that that number for each one. So I'm just going to again put a bit of protection in there. So I'm going to say if match results, I'm going to get that ID suffix out. So I'm going to say const ID suffix equals, and then that's going to be match results. And we know it's always going to be the second item. So let's put 1 in there. And then once we've got that, we can then push it to our array. So I'm just going to do test.push, and it's going to be an object for each one. So I'm going to push the title in, and then I'm going to push in the, I'm going to give it the test title, which is going to be the camel case version of the title, which I've already imported from Lodash up here. And then we're going to give it that selector ID as well. ID equals test prefix dash ID suffix. There. So the reason why we use this, we pass in the selector ID, is so that when we actually take the screenshot, we only want to take a screenshot of this actual div. We don't need to worry about all of the surround. We don't want to take a picture of the whole body. So we do everything in isolated mode here, which gives us a direct URL. And then we don't want to take a screenshot of the whole window. We just want it of this wrapping div for each one. So I'm just going to close that. So now we've got our tests. We've now got them all in the array. So it's going to go through every markdown file and generate us this object for each one. So now that we've got that test, we can come back into our main generate test function. So we're going to again put a bit of protection on this. So we're going to say if tests.length greater than 0. Then we're then going to create a new test config, which is just going to contain the component name and the tests, and then that's going to what we're then going to pass through our EJS file. So I'm going to say const test config equals component name and tests, and then I'm then going to await my write test file. And I'm going to pass in my template file, which is up here. This is the path for this. So I've got my template file, and then I'm going to, I need to give it an output directory. So I'm going to use our component directory here. So I'm going to use path.join again. So I need to stringify this. Path.join, and then it's going to be component directory, source, and then that's then going to go into, and again, we always follow the same format, so it's going to be component name, dot UI dot spec dot JS. And what's just happened there? There we go. And then the final thing I'm going to pass in is the test config. So then that is then going to take all of those three things, and then we're going to return a promise. So we're going to do an EJS rendered file. So we're going to take our template, pass the config in. EJS, the render files gives you like a third object where we just put params in, but we don't need them. And then it gives us an error or a string. And then we're going to then just going to use write file sync to go into that output directory and just publish that that string. So that's just going to be that one file there. So now we've got that written, we can now come into our EJS file here. So I don't know how familiar everyone is with writing EJS stuff, but we use it all over the place. We use it in our component generator, where we basically can just run like a very simple function that will give us a brand new component straight out of the box. And then we've started using it in here as well. So we're going to say, so this is going to be just plain JavaScript here. So I'm just going to write const component name equals, and then this can be in a string because this is there when our EJS comes in. So it's going to be equal to component name, and then just close it off there like that. And then we then go into our loop. So the first thing we do is we need a describe block. And then that is then going to describe the, and this will come in as just standard JavaScript here. So we just want a template literal here. Component name there. Like that. And then we can then loop through the tests object in our config. So our config is obviously made up of the component name and the array of tests. So we can just loop through that here. So we can start off an EJS tag, and we can just say tests for each, and then that's going to give us a test and index. So that's our our opening tag, and then we're then just going to close it back down here. So we've got our loop set up now. So now we can start to say, now we can go back into the normal format of writing tests. So we can say it, and then we're just going to say use EJS here and say test dot title in there. And then we can then start to use all of our usual tags here. So we're going to say cy.eyesOpen to initialize our Applitools test. So we're going to give it there we go. Let's just throw it in there. So we're going to run this cy.eyesOpen here, and we're going to give each one a unique test name. So we're going to say test name. And then this is where we then use our camel case version here. So we're going to put in our component name, dot, and then we go into EJS here equals test dot test title. So this one here, this can just be like this will be like a normal string. So we'll just say like appearances without favorite. This will be a perfectly readable string, whereas this is our unique ID. So we have that as the camel case version here. So then we close off our EJS there, and just finish the object. So for each one, so the way Style Guidance works is that every example has a unique isolated mode URL, which looks like this. It's very straightforward. So it's just the URL of your doc site with these little characters in, and then it's always the component name /1. But the way that it works is it sees this as sort of being /0. So then this is /1, this is then /2, and then this here is then /3. So we always need to access the odd numbered version of it. So that's why when we go into the cy.visit, we then need to use this. That's why we then pass the index in. So it's going to be /hash exclamation mark component name / and then I'm just going to copy and paste this bit. And that's just going to go there. So we've got our index +1 multiplied by 2 minus 1. That will give us the odd numbered version of each one. And then we then run our cy eyes check window. And then that's then going to give us, so we want to tag it up with the component name, which we've got as a variable at the top. We're going to target the region. And our selector of that region is going to be EJS tag here. So it's going to be test.selector ID. Like that. And then once we've done that, then we just run cy eyes close. So that's our template written. So we basically, it's a very straightforward loop of tests here. So now this is now still the moment of truth. So I'm going to stall for as long as I possibly can on this. So we've got our write test file up here. We've got the parser here, which reads through the markdown file. And then we've got our test generated down here. And then we are running it at the bottom. So we've already got the script set up in our root package JSON. So now if I run yarn visual tests generate, in theory, there we go. So now if I go over to Git, you can now see that we've got our webinar card UI spec file, which looks like this. So it has written out our component name as a describe block. So this is still in JSX. This is fine. So then we run through appearances. We then got it without a favorite, without a subtitle, which created this a test for each one. And because I've already got the doc site open, I can now run yarn cy open. And then go to end-to-end testing. And once it has configured, I've then got my Chrome test here. And then we've got our webinar card UI spec here. So now I can run that. So then we can see that it's visiting the stuff. It hasn't quite got the component name. I think I must have put a typo in there, but you can see we've got our appearances tests, our without favorite tests, and then our without subtitle tests. there. So that obviously is then there. It's going through and cleaning up at the end and putting all the tests into Applitools. So now if I go into Ives Applitools, I think it's this one. And then we've got our source web, and this is the batch here. So if I just clear that, then we can see all of these screenshots in all the different breakpoints for all the different tests. So we've got desktop, iPad mini, iPad, desktop, iPhone 11, going through for each one. So for each one, we've got a brand new test here with a full history on it. And obviously that is infinitely extendable. So I'm going to try, so what we've done here, if I just stop this and then I'm going to discard all this work here. So if I now run git checkout main and head over to our main branch, then you can see how this is actually sort of written. So we've got everything as a sort of separate function. So we just come in and run this index file, and we want to just run it for a couple of locations. So we run the generate test folder, which goes into here. It's exactly the same as we've just written, but a little bit more extended. So we write UI tests and accessibility tests for each one using Cypress Axe. And then we've got a couple of templates up here. And then it all goes into like a separate directory. So now if I go into atoms and then go into like the number badge, for instance, and go into tests, then we've got our accessibility tests. These are all auto-generated by this generator. So we've got our accessibility ones and our UI ones up here. So I can run through. So if I do visual test generate now, this is going on for 250 odd components. And takes 7 seconds to do the whole lot. So that's our sort of 6,600 tests written, as David was saying. So in 7 seconds, we can write 6,500 tests quite happily. And yeah, I think that's all of the coding demo. So thank you very much.
Brilliant. Thank you, Ben. As you've seen, we have not burnt development effort. Ben wrote that script in about 30 minutes. Obviously, originally it did take us longer, but we tried to work out what we were doing. But essentially, the key takeaway here for anyone, and not just to do with component libraries, is when you're building things and you're thinking about repeatable patterns, think about those sort of key things that you know about. What do you know? What are your starting points? And then from there, you'll be able to automate. So for in our context here, we knew that the MD files were structured in a very repeatable way because we write them and we have a standard for them. So therefore, we can use those as a starting point for automation. So in your projects, I'm sure there is something that you can go, actually, this is repeatable. I'd be able to automate X, Y, or Z. And just to showcase, you can see in this video here that's showcasing, we have 6,600 screenshots. This is just a run through of Applitools Eyes with all our different components. A quick scroll down, you can see there are thousands in here. And if we run the whole regression suite, it does take a while, but the actual writing of those Cypress tests is 7 seconds to get to this point, as you can see here. And this is really ensured quality in the library. Because it's automated, we don't therefore need developers who come in to contribute to the library to understand Cypress. They can write the components, they can write the markdown files, and then when they commit the file, they also auto-generate the test, which ensures the quality of the library is maintained, and we can maintain to see visually what's happening in the library. So, Ben pointed out some of the improvements we've done already, but because they're templates, we can have visual tests, we can have accessibility, we can have performance. Basically, if something else comes up with Cypress, another plugin or another third-party library that we want to use with these components, we can just add another template and very quickly run through it. So we've already done it with accessibility using Cypress Axe, so we run through that and get a score. In the future, we could use Lighthouse and do a Lighthouse test on the components as well. There's huge amounts of opportunities here because we've built the framework to do the automation automatically. So that sort of sums up what we've done. Hopefully it's been useful to you. Hopefully you'll take some learnings away and you'll be able to sort of use them in your projects going forwards. And I'd say don't be limited by the choice of what's out there already. So, we were not limited by Storybook. We went for Style Guidist. A bit more complicated for us initially, yes. But we found a way with engineering. There's always a way. So thank you very much. Handing back to Pamela.
Awesome. Well, thank you, Ben and David, for that. That was a great presentation. We do have a couple questions from the audience. I'll go ahead and bring those up now. And audience, if you do have others, please add those in the Ask a Question window. All right, Ash wants to know, how does the Find Local Packages module work?
Do you want to take that one, Ben?
Yeah, sure. So, in fact, I'll share my screen again, and I will show you. So we have our tooling folder down here. So find local packages. I think it just uses find from find, and it basically just finds every single package.json file in a given directory. So we pass in the directory we want to use each time. So at this stage, we just want to use like our component directory here, and then it will find every single every single package, and then return us an array. So this is like the actual test working. So we have like a couple of locations where we want to run tests. So it's then going to go through for each test location. It's going to generate the tests, and then generate tests, runs that find local packages within that source folder for each one.
I think it's key to note this is decoupled. Like, you could use Learner. Learner has tools to find those sort of things, but as Ben mentioned, we're sort of decoupling ourselves from Learner, so we could pivot to another monorepo manager in the future if we wanted to. So we're trying to sort of make our code very agnostic of the package manager we're using.
Okay. All right. Related to that, there's another question. Knowing what you know now, do you still think Style Guidist was the right choice?
Yeah, good question. I think for what we built, yes, but in the future, what we're starting to find is we're deviating a lot from Style Guidist. We're sort of having to do quite a lot of hackery, I guess. Style Guidist, you can override every component. And we've started to override pretty much every component. And at that point, you start to question whether Style Guidist, we need it. Could we, for example, build our own? What are we actually using from Style Guidist? And fundamentally, the thing that we're using from Style Guidist is the thing that allows us to convert Markdown files into coded React on the page. And at that point, you're thinking, well, could I do my own? Could I write just JavaScript and just render that? There's a bit of live editing as well that Style Guidist gives us. And we quite like, being part of an open source project, which React Style Guidist is. But I think going forwards, we might start to look at whether we build our own and sort of fork Style Guidist and create a more customizable theming for it, because there are other projects within Vodafone that like what we've built and want that sort of styling. And at the moment, there is no way to share it because it's very coupled to our code base. What we want to do is sort of decouple it, and that's sort of something on our future roadmap.
Thank you. As other questions are coming in, I will point out to the audience, if you're interested in learning more about visual testing or actually anything around test automation, I encourage you to explore Test Automation University. It is an open, community-driven training program providing free courses to help automation teams. There are classes on visual testing. There are classes on any number of other tools, projects, methods, and ways of doing that. So again, you can scan the QR code on the screen for quick access, or visit testautomationu.applitools.com. I want to thank everyone for joining us for this live session. And of course, thank you, Dave and Ben, for leading this great workshop. As I mentioned, there will be an email tomorrow with a recording to this, as well as a link to the session materials. Be sure to connect with Applitools on your favorite social channels to hear about other workshops and free events. You can scan the QR code again on your screen to see some of our upcoming events and webinars. And thank you for joining us again today. We look forward to seeing you at a future event.